So the next unit that we're going to be dealing with here is chapter 5 in your textbook, which is electrons and atoms. Electrons are pretty important. We know that protons are certainly important. It describes what atom the substance is. The number of protons is the atomic number, which is what something is. But the electrons feel they're pretty important as well. And the reason that is obviously is because they will determine whether or not something bonds ionically, with covalently, the loss or gain of electrons versus a sharing of electrons. And so all these compounds that are made have a lot to do with the electrons and their bonding. So let's take a look at electrons and atoms. Now the first thing that we need to recognize when we look at it is that electrons, although they are particles, can act like waves. Okay, so the fact that an electron can, not only because it's a particle, but also the fact that it can act like a wave and act like an electromagnetic wave is pretty important. So let's talk a little bit about electromagnetic waves. One thing we need to recognize is the fact that there's an electric and magnetic field. Okay, electric and magnetic field. And that electric and magnetic field can be, I guess, drawn out. Let's see if I can draw something out. First of all, I do want to mention this. This is important, that this is two different fields. Two different fields. That's important for recognizing that it has the electric part and the magnetic. So let's go ahead and draw a line here. And now let's draw two fields. Down, back up, and down, sure. So that's solid enough in terms of an up and down wave. Now in this you can see that the wave is moving up and down, and would continue along. So we could call this our electric field here. Our blue field could be our electric field. A magnetic field, and this is kind of difficult to draw, but the fact that, and maybe when I draw like this, it makes a little bit more sense. The magnetic field moves in and out. So if you think of this blue field as our electric field moving up and down and up and down, it makes sense. And our magnetic field moves in and out and in and out. Okay, so the wave is going, and I always think this is kind of fun to do, it's going up and down and in and out, up and down. So as it's coming towards you, up and down and in and out. And so those are the two fields. Now, the distance here and here would be the same. I'm trying to draw it, and you can kind of look at it so that you can see it's kind of coming out towards you or going behind you in this situation right here. But there's your electric and magnetic field. So let's just understand, I'm going to draw electromagnetic, I'm going to draw some waves, and we're going to talk about some descriptions of them just with the up and down, just because it's difficult to draw the in and out coming out on a 3D drawing on a 2D sheet, but it does move along that way. So let's go ahead and define a little bit more about our electromagnetic waves, okay? Let's take a look at some characteristics of a wave. Okay, so some characteristics of a wave. So let me go right ahead and draw that wave again here. So there we are, and let me go ahead and grab yellow here. And up and down and up and down, etc. Okay, this is pretty good. The origin would be where the wave begins, flat line, okay? Now you're going up and then down, so up above the origin and then down below the origin. The description of the top of a wave is the crest of a wave, okay? The lowest part would be considered the trough of a wave, okay, of a wave. All right, so we have our crest and a trough, and they are the same height or depth, I guess you could say, from the origin. And the way that we describe that is with what's called the amplitude. So this distance to the crest and this distance to the trough from the origin is the amplitude. So the amplitude of a wave. Okay, we're going to see what this amplitude means for in just a second. Additionally, we would recognize that we could have something that has the same amplitude but a different wavelength. The wavelength is the distance from one crest to another crest, or so from the one crest to the next crest, or you could say trough to trough, or you could say origin and to the next origin, not just here, of course, but rather up and down, doing its full crest and trough. Those would all be considered wavelengths. All right, so let's take a little bit more of a look at this. And I'm just really going to define these words again here. Here we are. Okay, so your amplitude, origin to crest or origin to trough, and the amplitude describes the brightness or intensity of the wave of light. So the brightness or intensity of a wave of light. So something that looks like this will certainly have a different amplitude than something like that looks like this. Both waves, we can talk about electromagnetic waves, both waves, but obviously the amplitude here versus this left one is significantly different. And so obviously in terms of the brightness of the wave. Okay? The next thing that you heard me talk about was the wavelength, distance from crest to crest. And again, you can see that you may have, I put crest to crest, but it certainly could be trough to trough or origin to origin. But again, crest to crest is kind of easy enough to see. There you are. Notice that we can have a wavelength that differs from another one with the same amplitude. So notice, and then I kind of made it a little bit too quick of a bubble, but notice that this crest to crest is longer than this first red one here, let's say, but the amplitude, and again, my drawing is not great, but the amplitude is the same, okay? So that's a wavelength. Now, we describe wavelength with a little Greek letter. The Greek letter is, the Greek letter lambda. The lowercase lambda symbol. So this symbol right here kind of looks like an upside down Y, I guess you could think of it as. Almost like a little triangle. That's the lambda symbol. And that's for wavelength. And of course, wavelengths units are in some kind of like meters or centimeters or whatever it might be. It's a distance. Okay? The next description or characteristic of a wave is frequency. Frequency is how quickly the wave oscillates up and down. And the best way of describing that is this. This is a lot faster than this in terms of frequency. I hate to say faster, but how quickly it moves up and down. Notice that and I tried to draw it where the amplitude was the same in each case, but notice that this frequency on this one, much higher frequency. It's going up and down more rapidly than the first one, okay? Now I think a lot of us are already recognizing that if you have a short wavelength, you have a higher frequency. Notice this wavelength a lot longer. I'm going to describe that next. The variable we use for frequency is the one you just saw me draw a little bit earlier, is this nu. It's the Greek letter nu. All right. It's kind of like a little funny looking V. So wavelength is that, frequency is this. Okay. And the last little thing I want to mention about a wave is the speed of it. The speed of light. We're talking about electromagnetic waves, speed of light. We're going to talk about light waves. Speed of light, which its variable is c. I've seen s before, but the variable is c. The units, meters per second. Notice how fast it is. 3.00 times 10 to the 8th. So 1, 2, 3, 4, 5, 6, 7, 8. 300 million meters per second. In this, the meters this far, it's going 300 million of those in 1 second. Ridiculously fast. We know that the speed of light is super fast, certainly faster than the speed of sound, but that's that. I do want to mention before I move away from frequency. Frequency, the variable is the units is usually 1 over S, which is cycles per second. Hertz is the SI unit, but I commonly use 1 over S just because it's talking about cycles per second, how quickly it moves up and down.